Hello, and welcome to the Trepa Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. This video will cover Domain 2.6 Embedded Systems. Now let's get started. Embedded systems are small or lightweight computer processing hardware that is purpose-built for specific industries or hardware. Most embedded systems will have a standard OS like a Linux distribution or a Windows operating system, but will be built just to run one or a few specific tasks. Embedded systems make up a lot of the technology we use daily in our homes or out in the world. Most smart devices, gaming systems, vehicles, and planes will use embedded systems. Now let's go over some of these embedded systems. A Raspberry Pi is a small form factor computing device that functions just like your desktop or your laptop. It contains the same input and output devices as a regular computer on a single small motherboard. Raspberry Pis can serve many purposes. In my personal use, I use a Raspberry Pi to run a WireGuard VPN server for my home network so I can reach my NAS or my network attached storage from anywhere in the world. The next thing we're going to go over is an Arduino, and excuse me if I messed up the pronunciation. This is a microcontroller with a small amount of CPU and power that is often used to interface with lightweight devices like sensors, motion detectors, or lights. An FPGA, or Field Programmable Gate Array, is a type of computer that is purpose-built to integrate with embedded systems. An FPGA can also be redesigned to fit a manufacturer's specialized system. Another small form factor, just computing system. And now let's go over our SCADA or ICS. SCADA, which stands for Supervisory Control and Data Acquisition, is a term to describe the complex and large manufacturing plants and all the IT systems in it. ICS refers to the automation of industrial systems, and it stands for Industrial Control Systems. For the Security Plus exam, we will review some security measures for your SCADA/ICS systems, and we will learn a fundamental understanding of how SCADA/ICS IT systems work and their data flow. So in this slide, we'll go over a simple network layout of a SCADA or ICS system and go over each part of it. At the factory floor level, that's down here, right? This is going to be the actual plant. We will have equipment that will be the main components of the plant that produce the business's product, and this equipment will have sensors or other technologies that a PLC will control. A program logic controller will interact with our plant's equipment to feed it information or to gain metrics of how the equipment is performing. So that's this right here, this PLC talking to our pumps or our equipment. Our SCS, or Supervisory Computer System, will then control and monitor our PLCs. That's this right here. The Supervisory Computer System is the brains of the whole operation. This mini or large factory data center configures and controls your PLCs for purpose. The SCS is configured and monitored from the HMI, which is the human machine interface, which is just a computer, right? These are just SCADA terms, but this is just the computer or systems you use to control it, right? The HMI is controlled by an employee or plant worker, and the IT team and cybersecurity team will maintain and manage and secure the HMI. These SCADA/ICS systems also need to have protective measures on them. So from every step of the way, right, whether it's our PLC, our equipment, or SCS, we need protective measures. The communication protocols used to interface with the equipment, PLCs, and SCS should be encrypted. And now the Sec Plus exam does not cover the specific security protocols used in manufacturing, like DOP3 and other things we won't get into. But there are specific manufacturing protocols that you must be aware of as a security professional in protecting organizations' plant/factories, which Again, it's not covered in the Security Plus exam, so we will not cover it, but just something you need to know that equipment won't always be connected via Cat5 or Wi-Fi. There's other transmission protocols used in manufacturing. And then also, SCADA/ICS systems should be segmented from the rest of the enterprise. There should be a regular enterprise of systems and hardware, right? So a regular enterprise router, switch, our firewall, and this is a security exam, so we have our UTM maybe right here. This is our regular enterprise, right? Where all of our end users are, our accounting, our marketing departments, our enterprise servers like Exchange. That should be separate from our SCADA systems. SCADA and ICS systems should be considered separate from the rest of the enterprise. And we can do this by doing some physical separation, like by putting an air gap, physically separating our SCADA and our enterprise. Or we can do logical separation by putting firewalls or jump servers and VLANs on the network to have logical separation. And now let's move on to IoT. IoT stands for the Internet of Things and describes all the internet connected devices in our household, or even our enterprise may have a lot of IoT devices. IoT devices make our daily lives more accessible and honestly more fun, right? I can connect my Spotify app from my phone to my smart TV, right? I can control my thermostat from my phone. These are all IoT devices. Most IoT devices do not have encryption built in, and they're going to use weak defaults. And as a security professional, it's your job to ensure that IoT devices on your network do not present an easy attack vector. You have to ensure that IoT devices don't use your default credentials, which could be admin, then the password being the serial number. And you got to make sure that logically you have some segmentation if you're going to deploy IoT devices on your enterprise. Meaning, an IoT device connected to our enterprise Wi-Fi shouldn't be able to be on the same network as our research and development department, unless specifically needed, right? And then always change default username and passwords. And if there's no encryption, that's fine, but if there is, ensure you use it. And then in this section, Security Plus exam also wants us to cover VoIP, because our VoIP systems or our phones are considered an embedded system or device. So VoIP stands for Voice over IP and is a standard telephony system used in the enterprise today. VoIP systems will have a call manager or server that configures the phones at your user's desk, right? Via TFTP, gives it a boot file and a configuration file. And phones themselves that sit at the user's desk are considered embedded systems because they're going to contain a lightweight operating system that is purpose-built just for phone calls. VoIP systems or the voice network should logically be segmented on your network. This is typically accomplished by using VLANs to separate voice traffic, and this will enable you to put QoS on that voice traffic or to just logically segment it, right? Major hardware and software providers like Cisco will actually use a specific voice VLAN to separate phone traffic from regular user traffic. Let's go ahead and take a look at what that looks like. So here you can just see a quick document of what using a voice VLAN is like. You have a regular user on VLAN 15, and then the voice VLAN is VLAN 5, giving that logical separation. All right, I want to thank you for viewing this video, and we look forward to seeing you in our next video where we'll be going over Domain 2.7 physical security. Thank you.